Okay, average value. That's what we're headed for today. Let's start with a function. We don't really care what it looks like. From A to B. So your picture doesn't have to look exactly like mine. Got some function. And we want to find the average value. In fact, let's let k, so I don't have to keep writing average value every time I want to say it, equal the average, I'll call it the average height, or the average value of the function of f of x on A to B. So somewhere, only looking between A and B, the average value is going to be some place in the middle-ish where part of the graph is above and part of the graph is below. So I don't know, something about like that. So that's like an eyeballed version of the average height, right? Because I don't even care about the stuff outside of A to B. Just from A to B, it looks like the middle-ish value, the average value is right about there. And our job is to come up with a way to figure out, well, what exactly is k? Like, I mean, okay, that's a fair enough eyeball approximation, but like, is there a way to get exactly what that is? And to make that k exact, we would want, here's where the formula is going to come from, we want equal areas. We want the rectangle area so the area under just the line y equals k, that rectangle area, we want that to equal the area under the curve. And my guess looks pretty good here because I've got some blue area up here that's it's only in the blue, and some red area down here that's only in the red, and if those equal each other out, then I've got k. So let's pause there. Does that make sense? The concept of what we're trying to do is make those areas match. Okay. Well, we can come up with a formula for each of those areas. The rectangle area, the red area, that's just a rectangle, so that's just height times width. So k times b minus a be the rectangle area. Thank you. Yeah, she's here. No, we'll say it's 9:35-ish, right? Ish. How about the area under the curve? What expression or what calculus thing do we use to find the area under a curve? And the antiderivative, or the integral. So that's the antiderivative of f of x from A to B. Okay, well, I started this problem trying to figure out what the average height is. I'm looking for k. So if I divide b minus a to the other side, I'll have k. Now, it seems like you just stick it underneath there, but every single textbook puts it out front like this. 1 over b minus a times the integral from a to b of f of x dx. And that is the average height of the function, the average value of the function between a and b. And yes, it is always on the AP exam several times. Right? Like there's some formulas that we hit in here, and it's like, well, if you forget that, maybe they won't test it, or if they do, it'll be one problem, and whatever. This one, it will be on there. It will be on there multiple times. probably in the free response as well as the multiple choice. So this is an important one. So I'm going to rewrite it down here, although I'm going to write it first with sort of the concept way to figure it out, because that's how I remember it, rather than remembering all the details. My brain remembers this picture, and I know that the two areas have to be equal. So it's 1 over the width times the area, or the area divided by the width. Again, that doesn't really help you, unless it helps you remember the details of the formula. So 1 over b minus a, that's 1 over the width, times the integral from a to b of f of x dx. Super important, got to know that formula. 1 over b minus a times the integral from a to b of f of x dx. Tells you the average value, the average height of the function. Okay, so before we move on, it's not difficult, it's just you got to remember it. I can also say that, or remind you that when it comes to evaluating an integral, sometimes we can antiderivative by hand. Sometimes we use geometry, like we're thinking about area. Sometimes we could use the calculator. And we could also approximate it with a Riemann sum. So there's lots of ways that they can combine average value questions with all this other stuff. And so that's why it's a frequent flyer on the free response section. It's because they can ask one thing and cover multiple stuff with that one thing. So you got to know what average value, how to get it, but then you have to know how to find that antiderivative. Sometimes it's by hand, sometimes we use the calculator, sometimes we use geometry formulas, and other times, like if they give you a table, they'll say approximate it using a right-hand sum, or approximate it using the trapezoidal rule. And so it's one formula, but there's a whole lot of things we can do with that one formula. Okay, on to some examples. So 1 through 5 was derivative of an integral, so that's fundamental theorem of calculus stuff. Number 6, find the average value of this function between 1 and 4. Okay, well, let's do this one without a calculator. So 1 over 4 minus 1, antiderivative from 1 to 4 of the function. And that will tell us the average height, the average value of that function. So this one is like by hand. I've got to know my antiderivatives. So let's pick on some people. Jake, how about the antiderivative of 3x squared? Yeah, well, the derivative of x squared would be 1/3 x cubed, but then there's also a 3 there. So in the end, it would reduce to x cubed. Molly, how about the antiderivative of 2x? X squared. Right, x squared over 2, but there's already a 2 there, so it cancels. And then from 1 to 4. I see a safe stop in our near future, but not yet, right? Because we have to plug in the 4 and the 1. This is not calculator ready. There's not a calculator where you could type that in and make that work. It's also, what's left is still calculus stuff. So we need to plug in the 4 and the 1, and then we can be done. Although we need to be super careful because parentheses and minus signs. 4 cubed minus 4 squared minus 1 cubed minus 1 squared. To make sure the 1/3 goes to all of it. So be careful with parentheses there. That is a safe stop. So if you're worried about messing it up from there, box it up and be done. I'm going to keep going because this is going to be a multiple choice type question where they'll want a better answer than that. I shouldn't say better, a more simplified answer. There's nothing wrong with that answer. Let's see, 4 cubed is 64. 4 squared is 16. 1 minus 1 is 0, so that was kind of nice. And then 48, a third of 48 is 16. So our simplified multiple choice answer is 16, but given an option, we would safe stop that and leave that alone.
For the minus 1 squared, would the squares keep it as still minus 1 to where it's, or would it be plus 1 there since the square?
Well, I'm doing the insides first, so 1 cubed minus 1 squared is 1 minus 1 is 0. Okay. Now, if you want to distribute the minus sign first, that's fine. It would be minus 1 plus 1. All right, the minus minus becomes a positive, and then those add together to be 0. So either way. All right, why don't you try number 7? But why don't you grab a calculator and let the calculator do the hard work for you. So I need to see the setup, but then you can go to the calculator to let the calculator do the antiderivative. So type it in the calculator, you get 6. I do want to address, Samantha, what you just said, doing the 1/3 later. Like I usually do that as well. Like I just put in the math 9 and 0 to 3, 9 minus x squared. The trouble with doing it that way is, and it's not a trouble, it's just you better remember to do the 1/3. Especially as things get harder and more complicated. Like it takes a while to find all the buttons and the square root and the e to the and the parentheses. And by the time you get all done, you're like, whew, my answer's 18. Like, well, no, you forgot about the 1/3. So my encouragement is to throw the 1/3 in at the beginning, although I completely understand doing this part first and then just doing dividing by 3. Just don't forget to divide by 3 if you're going to do them separate. Sarah?
Are you going to get a calculator on both minus?
No, I think it's all no calculator on the test, which means you're not going to get anything crazy to take an antiderivative of. Number 8. Why don't you try number 8? Try number 8. It's kind of the same thing. 0.375. Again, pretty easy. This is another one of those things where when we're doing all average value things, it's pretty easy because you just do the same thing over and over again. You get into practice on it. The tricky part will come later when we shuffle all the things up, and then one question's a fundamental theorem of calculus, and the next question is average value. Do you remember what to do where? One more comment on this, and then we'll move to the worksheet. When you're showing your work, like this is enough. You can use h of x. You don't have to put the actual formula in there or the actual expression in because the expression is defined right there. So this is an acceptable amount of work shown. And that, who cares if it's just 1 over x cubed? But sometimes that's helpful if your function is really long and crazy. Then you don't really want to write it all again. You'd rather just say h of x, and that's okay to do. Again, if it's 1 over x cubed, it's not a big deal. But if it's one of those crazy ones, like if you had to do something like this and you didn't want to rewrite all that, you could just use f of x.
Why did we put 1 on the bottom and 2 on the top
for the limits? You're always going to go from the smaller one to the bigger one. If you have the choice to set it up, you're always going to go from A to B.
Okay. Well, on number 7, didn't we go 3 to 0? Oh. No. Never mind.
If you do it backwards, you're going to get, the sign's going to be backwards. You can handle it, but yeah, just go smallest to biggest if you have the choice. If you've got one that's backwards, then my suggestion is flip it back to normal and put a negative sign out front. And then you don't have to worry about it. All right, we're going to pass on number 9 because there's one closer to what I want to talk about. on the worksheet. So back to the worksheet, and let's do number 7 by hand, or no calculator, just for practice, and then after that we can go all calculator after that. So do 7 and 8. Again, we're now working on the worksheet, but we're going to finish the worksheet before we leave today and get started on the review. Kind of peeking ahead. We'll also have Friday and Monday to work on the review as well. So we got plenty of time to look at the review. All right, so try 7 and 8. 7 without a calculator, 8 you can use a calculator. All right, well there's 7 and 8. 7 you could save stop, but it simplifies to a nice answer. Samantha, you say you didn't get that one in the calculator? Number 7? Okay, let's check this in. Math 9, 0 to 3, x squared, minus 2x, dx. I got 0. I guess divide by 3, but obviously that's still 0. And then number 8, just a straightforward calculator question. But even on those, again, do not just put 2.167. I need to see what you typed in the calculator. I know the calculator does the work, but I need to know that I need to know that you knew how to get that answer. You didn't just copy it off a neighbor. All right, take a few minutes to do the next page. You can use the calculator on all of them. Very straightforward. Maybe until you get to 14. 14 may be a challenge.